In this lesson, we're going to go over the relationship between the areas of rectangles and triangles and learn how we can then go ahead and apply the area formula for triangles to solve math problems and real-world problems. Okay, so first, before we go on, let's make sure we understand how to classify triangles by their angle measures because this comes into play when we're looking for heights of triangles. Okay, so first, triangles are three-sided polygons. So quadrilaterals, 4 sides, triangles, 3 sides. Triangles have 3 interior angles. So when we're looking at the angles, for example, down here, 1, 2, 3 angles. Okay, 1, 2, 3 angles. 1, 2, 3 angles. So when we're classifying triangles by their angle measure, however, I'm trying to say, just like we talk about acute, obtuse, and right angles, we can classify triangles this way as well. So when we're looking to see if a triangle is an acute triangle, obtuse triangle, or right triangle, we look for the biggest angle or the one with the greatest angle measure, and that tells us what type it is. So if I look at this one right here in the middle, I see that this angle over here and this angle over here are both less than 90 degrees, but this one is exactly 90 degrees, making this a right triangle. But if I was going ahead and I was looking at this one over here on the right, well, this angle right here is the biggest one. And I see that if I put that little square there, remember the square has 90-degree angles, this angle that it's touching is bigger than that 90 degrees, which means that this is a triangle that has an angle that's greater than 90 degrees. It doesn't matter how big it is, as long as it's greater than 90 degrees, that means it's an obtuse angle, which makes this an obtuse triangle. And if I go ahead and look at this one over here, and I looked at all of these angles, I see that this one, if I go ahead and line those up, that angle's less than 90 degrees. This angle over here is less than 90. And if I rotated this a little bit, that angle there is less than 90 degrees. So if all of the angles are less than 90 degrees, that's how we go ahead and say that the triangle is acute. Whereas right triangles and obtuse triangles only need one of their types of angles in order to classify them. Okay, so now we're going to go ahead and we're going to jump to this link, and it should be in your notes too. And if you go there, you can join me with what I'm going to do. I'm going to form a triangle, and so I'm going to grab a rubber band, and I'm going to put it up here. And now I'm going to stretch it, and then I'm going to grab it in the middle, and I'm going to stretch it over here to this peg that's one over to the right. Okay, so if I wanted to figure out what the area is, I know that normally I would go ahead and I would say, okay, well, this would be, the purple would be 1 square unit. Well, I can't actually go ahead and say that I have 1 square unit here in this triangle. So I have to figure out another way to go ahead and find the area of that triangle. Okay, so to figure out how many square units I am, I'm going to try and figure out a way of making this triangle into something that has a bunch of squares. So I'm going to go ahead and I'm going to make a rectangle with a new rubber band, and I want that rectangle to have the same height as the triangle, and I want it to have the same base as the triangle, but I want it to be a rectangle instead. And voila, there I am. To make it easier to see what we've done, I'm just going to go ahead and back to my red, and I'm going to shade it in, which I do by just hitting that there. Okay, so now How do those two compare? Well, hopefully you see that that red triangle is exactly half of that yellow rectangle. And so we can easily see that two of those squares on the geoboard make up the area of that one rectangle. So let's see what we have. Okay, so we took that red triangle that had a base and a height, and we made a rectangle with the same base and the height. And so when we go ahead and we took this piece off, we're left with the triangle. Well, how do those two relate? Well, this piece over here is the same as that, so it's like I have two of them. So what it means is, what I started with was a rectangle, and the area of the rectangle we know is base times height. Well, since this triangle takes two of them to make one rectangle, that means the triangle is worth half of the rectangle. And that's how we get that formula for a triangle that says that the area of a triangle is exactly 1/2 the base times the height. And that's because base times height is what we had when we had a rectangle. And another way of writing it is dividing by 2, because remember, multiplying by 1/2 is the same as dividing by 2. So the relationship between the area of a rectangle versus area of a triangle is, it's the same formula divided by 2 gives us the area for a triangle. So one more thing before we go on and do the actual applications of finding areas of triangles. We want to make sure we understand how to find the heights of triangles, and that's because where they're located is different depending on what type of triangle it is. So let's go back to our geoboard. So that triangle that we had started with before, its height was 2 and its base was 1. And that's because we have a right angle right here. But now let's go ahead and I'm going to change where a little bit about it. So I'm going to go ahead, I'm going to make the base now 3, but now I'm going to change where the vertex is. So now there's no right angle in the triangle, and so my height, when I'm going ahead and actually looking at it, is different. The height always has to go from a vertex at a right angle to the opposite side. So that means the height has to be inside of this triangle. And this type of triangle is acute because all the angles are less than 90 degrees. So now let's look at what would happen if we had an obtuse angle. Okay, so this is an obtuse angle, and I want to find the height. So in this case, if I go ahead and I can't use my geoboard to do this one, to find the height the way I did before, because if I go ahead and I did from here to here, that's not a 90-degree angle. And if I went from that one to the opposite side over here, well, it won't touch the opposite side of the peg, and it's definitely not a 90-degree angle, and that's not going to be at a 90-degree angle, so can't do it that way. So sometimes we have to get a little creative with an obtuse angle. And so how it works is sometimes, but not all the time, it depends how we go ahead and rotate this. I'll show you a different way. We can go ahead and we do what we call an exterior angle. And so what we do is we go ahead and we extend one side, make it a little bit longer, but kind of fake it. And I'll show you a little bit more when we go back. And then we draw a perpendicular, or that height, and we make and force it to have a right angle. And this piece right here would be our height. So in this triangle, our height would be 2, and our base would still be 3, because this part isn't actually part of the triangle. But this tells us how tall the triangle is when we measure it from perpendicular length. Okay, so again, the definition of a height of a triangle is it's the perpendicular distance, which means it makes a 90-degree angle, from the vertex to the opposite side of the triangle. And so the easiest ones to find are always going to be in a right triangle. So in a right triangle, the height and the base are always going to be connected by a right angle. And it doesn't matter which one's the base and which one's the height, but it's pretty easy to just go the tall one is the height and the bottom one is the base. So for example, if we rotated this and I went ahead and I moved it so it was like this, I could go ahead now and I could say that this is now my base and this one is now my height. When I'm looking at an acute angle, it's always going to be on the inside of the triangle. And I use a dashed line to represent that it's not a side, but it's a height. And I always use that square to represent 90-degree angles, so we know that the two things that are connected by the 90-degree angle, one of them is going to be the height, and the other one is going to be our base. And in this case, 17 centimeters has to be the base because it's a side of the triangle. Okay, now this is an obtuse triangle, but remember that not all the time does it have to be outside. This is just an example of when it is outside. So we extend the side and we go ahead and say, I got my 90-degree angle. And so what is connecting the 90-degree angle? That would be this. So this is my height, and this, and it's part of the triangle, so it's my base. So sometimes we have it on the outside of an obtuse triangle, but not always in an obtuse triangle. Okay, so now let's actually calculate the areas of the triangles. So it doesn't matter which version of the formula you use. When you're trying to find the area, I prefer the one that goes base times height divided by 2, and that's because sometimes students get intimidated by fractions. So I use this one. Okay, so first thing is identify what's your base and what's your height. So I look for my 90-degree angle, and I know that the side that's touching it is my base. And if there's no other side touching that one, then if I see that dashed line, that means this is my height. So now I substitute. So 20, I don't use centimeters in that, times 8, which is my height. So I'm replacing my variables with the values, divided by 2. And now I do my math. 20 times 8 is 160. 160 divided by 2 is 80, and now I do my units. So if it's centimeters and I'm doing area, it's square centimeters. Okay, so here's a right triangle. So with the right triangle, sometimes it's not easy to see what's the base and the height, but we still look for our right angle. And again, it doesn't matter which one's the base and the height in a right triangle as long as you're choosing the two sides that are connected by the right angle. So in this case, I start off with my formula. Make sure you're choosing the right one, and make one of them your base and one of them your height. And again, it doesn't matter which one is which in a right triangle only. So 3 times 4 divided by 2. 3 times 4 is 12. 12 divided by 2 is 6. And then my units is square feet. Okay, and here we have an obtuse triangle. So my formula is area is base times height divided by 2. Okay, and here is my right angle, and these are the two things that are connected by the right angle. So one of them is my base and one is my height. And in this case, this has to be my base and this has to be my height because it is not actually part of the triangle. So my base is 4, my height is 8. 4 times 8 is 32. 32 divided by 2 is 16, and my units are meters squared. So now let's go ahead and apply the math that we just learned to a problem. When law officers are trying to find someone by their cell phone, cell phones actually do something called triangulation. So if you're standing here in this area and you make a cell phone call, your cell phone signal goes to the nearest cell phone towers. And a lot of times they can do something called triangulation to figure out about where you're at. Maybe not exactly where you're at, but approximately. So here's what's happened. They have a suspect and they've triangulated the location of the last cell phone call to these 3 cell phone towers in this area. And we need to figure out what is the actual area that they need to find the suspect in. So here's what they know. Cell phone tower 1, C1, okay, and C2 are 5.6 miles apart. Cell phone tower 2 and cell phone tower 3, so that's these two, are 7.5 miles apart. And cell phone 1 and cell phone tower 3 are 5 miles apart. We want to know how large is the search area for the suspect. Okay, so what is our base and what is our height? So we know that the area of this, being that it's a triangle, is the base times the height divided by 2. So here's my right angle, and I know that one of these has to be my base and one of them has to be my height. And since it's a right triangle, it doesn't matter which is which. So I'm going to use 5 6/10 as my base, 5 as my height, and now I go ahead and I do my math. So when I multiply 5 6/10 by 5, I get 28. And when I do 28 divided by 2, I get 14. And my units is square miles. So the search area is 14 square miles. And that's a lot of space to search.